Welcome to artificial intelligence. Let's start with the standard question that you ask. They do in every class. What is insert name of course here? Which is, in this case, artificial intelligence. Decision-making process. Anything else? Program think for itself. Yeah. Yeah, okay. What is artificial? Man-made, fake, lesser, not as good, phony, any of those, not natural.
Isn't it kind of better?
Better, maybe? Yeah, okay. So 90% of you are wearing synthetic fabrics right now. Are they better? Well, I mean, everybody thinks cotton's better because it breathes more and it's natural and it makes you feel good. But so why are you all wearing synthetics? Yeah, cheaper. So you've got maybe the price to benefit ratio. All things considered, somehow we seem to think that the synthetics are better. And yet there's something about nature that we just prefer, right? Isn't nature kind of better in some ways? And yet overall, the artificial fabrics are totally winning. So here's an obvious example. If you go onto a movie stage and they've got foam and the foam's been chiseled to look like a rock and spray painted and it looks like a rock, but we all know it's an artificial rock, right? If you hit somebody over the head with it, the foam will break, the head will be fine. There you go. Whereas a real rock is going to be big and heavy and hurt the guy's head. So artificial intelligence is intelligence that breaks over heads and is light and is easy to pick up, or something like that. That's a really terrible analogy. Yeah, exactly. The man-made aspect is what it's getting at. The fake or lesser thing is kind of what I want to contest really fast. So let me give my best attempts to do that. I have brought a needle here. Usually I bring a nail, but I neglected to pick up a nail and I happen to have a needle in my bag. So here's a needle. I need a volunteer to drive this needle through my skull into my brain.
Well, I guess I'm close.
Nobody volunteers? Okay, there you go. But there's a catch, of course, as there always is. You have to do it with this rock. Yeah,
you're like a picture of you, and then
yeah. So here's the game I'm getting at. Obviously, I don't want this needle driven through my head, and so I've picked a artificial rock here, a virtual rock, because you can't pick it up. If you try to grab this rock off of the screen and hit this needle in my head, you can't do it. One cannot pound physical nails with a virtual rock, right? However, you can pound physical nails with a physical rock. And you can pound virtual nails with a virtual rock. So a lot of people using this analogy will say, there's something very different between artificial intelligence and biological intelligence. I have biological intelligence here between my ears. We have physical intelligence here in the machine. Now here's my question for you. Good analogy or bad analogy?
It's a bad analogy.
Well, let's do another analogy, and then we'll see which one works better. So I'm going to click accessories, calculator here. Let's do math. First I'll do it on my fingers. I'm going to add the numbers 2 and 3. We'll do it Sesame Street style. Take a 2 over here and a 3 over here. 2 moves a little closer, 3 moves a little closer, 2, 3, 2, 3, 2, 3. And then we count them up. 1, 2, 3, 4, 5. 2 plus 3 is 5. No one's impressed. Now I'm going to do math using a virtual fingers. In fact, I'm going to enter a symbol here. Those are not 2 real fingers. That's a symbol that we use to represent 2 things. Could be 2 fingers, 2 rocks, 2 whatever. I'm going to make another symbol and another symbol. I have not held up 2 or 3 fingers here. I've just entered symbols, but you understand that means the same thing as the Sesame Street game, right? And I'm going to press enter, and it gives me yet another symbol, which we know means 5, and we pull this into our brains. Is the answer the same? Nobody said no. Well, I mean, that's a symbol, and these are fingers, right? And because this is virtual, I did not do real math. I did artificial math right there, right? I mean, that's not even a real calculator. Try to pick it up. I'll do it for you. You can't do it, right? I have to be dramatic. It's the first day. It's the day for stupid demonstrations. But that's not even a real calculator. It's a pretend calculator using pretend representations of numbers, which are pretend concepts that are artificial for representing real things. Is intelligence more like a rock that cannot pound virtual nails, or vice versa, a virtual rock that cannot pound physical nails? Or is intelligence more like math, where it doesn't matter if you do it artificially or for real, because it's the same thing? Depends on the application? Yeah, so try to write code that will wash your dishes. It's darn hard, unless you happen to have a really flexible robot. And if you do, why not? What goes on in your head, is it different from what goes on in the machine?
Well, isn't that the...
So obviously, if you want to affect the physical world, there must be some interface. At some point, all the processing and math and computation you do has to go affect these servos, which are going to have end effectors that are going to touch the real world. But you can't get out of the virtual world unless you have some kind of an interface. Okay, I'll just get to my point because I think we've belabored this far beyond its value. I don't think there's any such thing as virtual intelligence that's any different from real intelligence. If you were to break open your skull, what would you find? A brain. A brain is a physical device, but somehow in there is your mind. But it's not really in there at all, in the computer. It's implemented in symbolic form and representations in your brain. Your brain actually uses neurons, and those neurons fire electrical signals. Do you see how there's a bit of an analogy with a computer here? The computer is a physical device, and it uses electrical signals to represent things, but ultimately, the intelligence, the thinking part, the part that matters, your mind, is just symbolic manipulations. And I am going to claim that whether I do it here on this virtual calculator or on my fingers, as long as I arrive at the right answer, the answer is right, right? There's kind of no difference. Reason I make this point early on is the class is called Artificial Intelligence, and I don't want you to think that, hey, everything we're learning in this class is only applicable for software implementations of solving these dumb little toy problems. We're going to spend the whole semester solving dumb little toy problems. Here's assignment 1. We're going to solve this puzzle here. When are you going to use this in the real life? No one's going to pay you to slide these things around in order to get that red piece out of its position. But we're going to solve this with a machine because it's a very simple problem and it demonstrates intelligence. And I'll scroll down here to our last assignment. Here we're going to have a capture the flag style tournament, and you'll all write artificial intelligence, and they'll battle each other, and bombs will be exploding, and it'll be so dramatic and exciting. And but again, this is not real war, it's virtual war because it's simple, it's a toy we get to play. But I hope you won't walk away from this class and think, I learned how to code for video games. Because in my opinion and strong beliefs, that which happens in your head is not that far distant from what happens in the computer. And I've found that the things we learn in artificial intelligence are highly applicable to life in a number of ways. So as the class proceeds, I intend to make all kinds of analogies to children and life and decision making and science itself and the very process of learning and the processes of making decisions. And I claim they're not irrelevant. So this class is not about artificial intelligence. This class is about intelligence. Why? Because all intelligence is artificial. Every last bit of it is done in symbols, it's just computation. But nevertheless, I think it's a fascinating field of study. It shows us how the world works, it shows you how you work, how people work, and that's really relevant to every possible aspect of life. So yes, all of our assignments are going to be simple and toys so that you can handle them. You're not going to code up Jarvis or Commander Data or, it would be awesome if at the end of this class you could write general AI. Unfortunately, Hollywood is a little bit farther ahead than science is in creating artificial intelligence. And by farther ahead, I mean what they imagine is science hasn't quite achieved yet. But we're also getting closer at a screamingly fast pace. I think it's going to happen. Maybe not in our lifetimes. It's very hard to predict the future. AI, anybody that tells you it's going to happen in 5 years, maybe. If they tell you 10, they're just guessing. Nobody has any idea. Technology is happening very, very fast, but at the same time, AI is a huge obstacle. The brain is the most complicated organ in your body by far. It's the only one we don't completely understand. And by completely, I mean well enough to synthesize a working substitute for it. Nevertheless, we do understand it a lot. And so let's talk about what we know, how intelligence does work, and half the things we teach will turn out to be obsolete in about 5 years. I apologize for that, but this is probably the fastest moving field in all of computer science. There's no way I can teach you everything to be absolutely true. But I will try to teach you the general principles, the things that have not changed and that have become established and that we're pretty darn sure that's how intelligence works. And it won't be too long before real intelligence is here, and maybe because you took this class, you'll get it. And those of you who stick around for graduate school and decide you want to research this, awesome. You'll learn even more, and you'll get to spend your time thinking about what makes intelligence happen and how it all works. And I'd encourage you to do that if you have yearnings and leanings towards solving the world's hardest problems. Even if you don't, if you just want to go to industry and make a fortune, there's a lot of money being thrown around right now for people with expertise in AI. So good field to get into, I think.